Hey guys, so this video is going to focus on how to subtract rational expressions. So one of the main important things that we need to remember about rational expressions is they follow the exact same rules as fractions. So if we're subtracting rational expressions, we need to keep in mind how to subtract fractions. There's 4 basic steps when it comes to subtracting fractions. Step 1, find the lowest common denominator. Step 2, convert your fractions to have that common denominator. Step 3, go ahead and add or subtract. And 4th and final step tells us to simplify if it is necessary. So our first step is going to be to find our common denominator. Now a little bit different or difference of finding common denominators for rational expressions is that if we have 2 or more terms in our denominators, it's always a better idea to go ahead and factor our denominators if possible. So taking a look at our first denominator that we have a 10x plus 15. So we need to think about our factoring techniques. Is there a greatest common factor? Can we use reverse FOIL? Can we do no fuss? Is it difference of squares? Is it a perfect trinomial squared, or so forth? Taking a look at 10x plus 15, the first method that you always want to start with first when it comes to factoring is to always check and see if you have a greatest common factor in your problem. So taking a look at 10x plus 15, we actually do have a greatest common factor here, because taking a look at the 10 and the 15, we have a 5 in common. And that means that we can divide out of 5, we can factor out of 5, and when we do so, remember that factoring out a greatest common factor is the same thing as dividing it out from the problem. We're just pulling that out to the front, and to figure out what we're left with here, we actually need to divide it out. So 10 divided by 5 gives us 2, tack on the x with it, drop down the plus sign, and 15 divided by 5 is 3. Now do the same thing for your second denominator over here. Taking a look at 12 and 8, looking for a greatest common factor. A 12 and an 8 has a 4 in common. So we're going to factor out that 4, and we're going to divide it out to see what we are left with. Now 12 divided by 4 gives us 3x, plus 8 divided by 4 is 2. So taking a look at this problem here, our factor denominators 5 times 2x plus 3, 4 times 3x plus 2. Now that we have our denominators factored, we can now look for what our greatest common factor would be. It's always best, especially since we have numbers and then we have polynomial factors for our denominators, we want to look at the 2 things separately. Starting with our numbers, the number 5 and the number 4. Remember, when it comes to having common denominators, we are looking for the first multiple that we have in common as far as our numbers are concerned. So our first multiple that we have in common as far as a 5 and a 4, remember that's taking a look at your times tables, 5, 10, 15, 20, 25, so on and so forth. 4, 8, 12, 16, 20, so on. The first number that a 5 and a 4 has in common would be a 20. So 20 would be our common denominator as far as our numbers are concerned. Now, as far as our polynomials are concerned here, you always want to list all the different factors that you have as part as your common denominator. So, taking a look at our variable factors, we have 2x plus 3, we have 3x plus 2. We just want to go ahead and tack those on to our common denominator. They are not the same, so we need to list them both since they are 2 different factors. Your lowest common denominator of rational expressions is made up of all the different factors that you have for your denominators. So a 5 and 4 had a 20 in common, 2x plus 3 was also one of our factors, 3x plus 2 was also one of our factors, and because those are different, we need to list them all. So actually 20 times 2x plus 3 times 3x plus 2 would be our common denominator for this particular problem. That brings us to step 2, which is taking our current fractions and converting them to have our common denominator. So we're going to take 3 over, we're going to want to use our factored denominator, and we want to convert this to have our lowest common denominator of a 20 times 2x plus 3 times 3x plus 2. And then we're going to want to do the same thing for our second fraction, 8 over 4 times 3x plus 2. And we're going to convert that to also have our common denominator. Keep in mind that when it does come to converting fractions to have your common denominator, we are looking at the current denominators that we have, and we are trying to figure out what do we need to multiply them by to get our common denominator. So starting with our first fraction over here, it's always best, in my opinion, to first compare your numbers, then compare your polynomial factors. Starting with our numbers, we have the number 5, but we want it to be the number 20. So we need to think 5 times what gives us a 20? Now 5 times 4 gives us a 20, so we're going to multiply by 4 over 4. We need to make sure that we multiply the numerator and denominator by that number. We can't just multiply the denominator, that's going to throw our fraction off. We need to make sure that we multiply top and bottom by it. Again, keep in mind that 4 over 4 is just the number 1. Multiplying by the number 1 does not change the value of our fraction. It just changes the way that it looks to suit our needs. So 5 times 4 is what's going to give me this 20. Then I need to look at my polynomial factors, and we have 2x plus 3, and we want to get 2x plus 3 times the 3x plus 2. So we already have the 2x plus 3, but we need to tack on this 3x plus 2. That is not currently part of our denominator. We need to make it part of our denominator, and the way that we do so is just tacking it on, going ahead and multiplying by it. So we're going to multiply numerator and denominator by that 3x plus 2 because that's what's missing. Now we do need to go ahead and multiply this out together. So remember that fraction multiplication is straight across, numerator times numerator, denominator times denominator. So over here technically we have this 3 times 4, then times 3x plus 2. Now I'm going to go ahead and I'm going to do this multiplication down here at the bottom. 3 times 4 is a 12, and we're going to multiply that by 3x plus 2, which means that we do need to go ahead and distribute that out, giving us 36x plus 24. So that's going to be our new numerator. And we need to do the same exact thing for our denominator. We have a 4 and a 3x plus 2, but we need it to be 20 times 2x plus 3 times 3x plus 2. Starting with our numbers, we have a 4, we need it to be a 20. So 4 times a 5 would give us a 20. So that would be the first thing that we tack on. We're going to multiply by a 5 over a 5. Now we have the 3x plus 2, we need the 2x plus 3. Since that's what we need, that's what we're missing, that is going to be what we multiply our numerator and our denominator by. Multiplying that across, 8 times 5 gives us 40. Then we're going to multiply by the 2x plus 3, which is going to give us, let's see, 80x plus 120. And we're going to go ahead and tack that in over here. So our third step is going to be to go ahead and add or subtract these fractions together. So what we have here, we have 36x plus 24 over our common denominator. And we are going to subtract that by our second fraction here, an 80x plus 120 over our common denominator. Remember that when it comes to adding and subtracting fractions, we simply keep the common denominator. So we're going to keep this 20 over, times 2x plus 3 times 3x plus 2. And we're going to we're going to subtract our numerators together. So we're going to take 36x plus 24, and we're going to subtract that by 80x plus 120. Keep in mind that when you do subtract, you are only able to subtract like terms. So your x's are your like terms, so are your numbers. So we're going to do 36x minus 80x. So 36x minus 80x is going to give us a negative 44x. And then 24 minus 120. So 24 minus 120 is a negative 96. Otherwise, at this point here, our fourth and our final step is going to be to see if we can simplify. Let me make a little bit of room here on the board before we get to that part. So in order to simplify our rational expressions, simplifying rational expressions involves trying to see if anything on our numerator can be factored and canceled out with anything in our denominator. So taking a look at our numerator does look like it has a negative 4 in common with our numerator. So 44 and 96, we would be able to divide out a negative 4 from it. Remember, we want to tack on the negative to it because when it comes to factoring, anytime your leading term is negative, you do want to factor out that negative. And when we do factor out that negative 4, we are left with 11x plus 24. And we're going to tack on our common denominator. The only thing I'm going to change about our common denominator is I'm going to take this 20 and I'm going to change it to a 4 times a 5. Again, if you need a little bit more practice as far as this factoring is concerned, go back and watch one of the factoring videos that I have in order to refresh on those techniques. When dealing with rational expressions, it's absolutely necessary for you to be very familiar with your factoring techniques in order to work with this type of material here. So make sure that you do review that and you're very well practiced with your factoring. And the reason why I'm wanting to break it up this way is because I noticed that I have this 4 in my numerator. 20 has a factor of 4, so we want to take that 20 and break it up to a factor of 4. That way that 4 can be canceled, leaving us with a negative parentheses 11x plus 24 over our common denominator now. Since the 4 is the only thing that was able to be simplified, that does mean that we are done with this particular problem. This is our factored answer. For the most part, you don't need to multiply this back out. As far as your denominator or anything is concerned, for the most part, it is okay to leave your answer in factored form like this. But again, every class, every teacher is a little bit different, so make sure that you do read your instructions or you follow along with the method that your instructor likes you to leave your problems as. Otherwise, that is it for this video.